This lecture is about dynamic programming. We will illustrate the important concept of principle of optimality, and after that we will introduce three important application or framework in industrial engineering. However, for optimization is applicable to a lot of different industrial settings. You could search a dynamic programming, you could find several million results, which means that it's still a very active research area. It's an important tool to understand. This one is about the history of dynamic programming and published in Operation Research. And I is Bellman. And he's a friend of Paxson. And Paxson is working at RAND, which is a think tank. And Paxson suggests that multi-stage decision is important problem. So he followed his suggestion working on that. But at that time, it's not a good time for research. And Wilson is the boss of Air Force. And Ray is employed by Air Force. So how could Bellman cover his research without noticing by the other person he's doing mathematical research? So he need to come out with a good name. He used a programming about decision, and also use dynamic, which means it is multi-stage and is varying when the time is changing. So it come up with the wonderful name. It's called dynamic programming. Okay, so this is the origin of the name. Next, we'll introduce the fundamental idea of principle of optimality. The theorem says that if we start from B to E, and if you could find the optimal shortest path, it's path 1 and 2. Then, if you start at the middle, M1, to the end, the optimal route is the second route. That is, this is your destination, and you try to start from the middle of your optimal path. Your optimal path is part of the original optimal path. And the proof is easy by contradiction. Suppose not. You start here, but this path is not optimal. That is, we find path 3 and 4. Path 3 and 4 is shorter. Okay. So next step, you just add one more step, P1. So this is P1, P3, and P4. It's less than P1 and P2. But we assume P1 plus P2 is the shortest path. So this initial conjecture is not correct. So we call it contradiction. And also, this kind of proof is very popular in mathematics. So this is the fundamental idea we will encounter a lot. I'll give you an example to understand what is going on. On the left-hand side, we have optimal path. And on the right-hand side, we have myopic policy. So we need to start from the origin to the destination. At the origin, there are two choices here. And at this point, we have two choices. And this is the length of this path. Okay. So optimal is starting from the end and backward in time. And we'll give a detailed example how could we compute from this one. But from this simple example, as you can see here, if you start here to the end is 100 here. And this part to the final is 2. And for this part, there are two choices, right? 1 and 100, 5 and 2. So we choose the shortest path, which is 7 in this case. And also, there are 1, 7, and 4. And for this one, the path, the shortest one is 5. So 4 plus 5 is 9. We choose the shortest, so we go through this direction. So this is our total cost or objective function. My object is forward in time. You start from the origin and find the shortest one. In this case, you have two choices, right? One is 4, one is 1. You choose 1 here. And next, you choose 1. And finally, there's the only single choice. So you choose 100. So the total cost is 102, which is much larger than the optimal one. Okay, so the idea is that my object policy sometimes in a computer science course algorithm, you encounter some policy which is optimal, myopic and optimal, but there seldom have happened. Usually myopic policy is not optimal. Also, I want to mention that CART and random forest, they use greedy policy, that is myopic policy, to find the structure of a tree. So then it's very easy to understand visually. And in the dynamic programming, we determine an optimal policy and its corresponding cost. So this is the policy, right? And this is the cost. And this is a famous quote. Life could be understood going backward, but you live going forward every day. So that is the reason why we need to read some history books and memo to understand how could you design a purposeful goal. And different person have different life goals. And also, this is a popular book. It's called 7 Habits. Okay, so there's one famous. It says that you begin with the end in mind. So you know your destination, and how could you achieve your destination? Okay, so actually this is dynamic programming, right?